Hello, everyone. Welcome to another episode of Three Devs and a Maybe with me, Michael Budd, and my esteemed colleague, Ed Mann.
Hello, how we doing, bud?
I'm good. And you?
I'm very good, sir. Looking forward to doing some Git stuff today. Git stuffed.
Yeah. So for anyone who didn't listen to maybe the last episode or the one before that, we talked about maybe doing some podcasts on Git because, I shouldn't admit this, but I don't know it very well. And my experience to date is really using it as a glorified backup of code, which kind of I push it up and then I just never do anything with it again. So it'd be good to go to basics and have a look at how it works, what it is, what its purpose is. So this is really going to be from beginner level. So if you are a Git guru, then I would listen to some other podcasts.
Definitely listen to another podcast because you're getting your information from me and I'm far from a guru.
Well, I don't know about that, man. I don't know about that.
Definitely not, but I'm going to try my best to pretend to be semi-knowledgeable about Git today. We'll see.
Yeah. So should we start off with that question then? What is Git?
Yeah, I think that's a good idea. So essentially, and this is like the buzz around it, is it's a distributed version control system, which essentially means version control systems in the past, such as Subversion, what they required you to do was have a master server where all the files were available. So this was where the source of truth was, and you would essentially check out the files that you needed. You say, "Oh, I'm working on these files," and no one else could actually work on those files while you were doing that work on it, because it needed to always be the fact that was the source of truth. So you would always push up to the source, the Subversion, master repository. And, then people would come back, and stuff like that. So you could do things like branching, but it wasn't really called branching then. I can't remember exactly what it was called. But, so essentially what distributed means is that it allows us to work on a full set of the whole code base. So I'm not only just checking out the files I need and stuff like that and working from that way. I've got the whole source code, the whole history on my computer, or my laptop, and I'm able to do anything I want with it. And the way we get around, is we then merge things in together and push it into. We don't need to have that idea of master, though we still keep the source of truth. Master being where all the source code should be. Where the real pure build is. So what one that's actually shipped. So typically, master is what's currently on live, and then we're going to be branching off from master, doing some work, maybe adding a feature, maybe doing a bug request. Bug fix, and then doing a pull request on that and merging it back into master to then deploy it using things like tags, and we'll talk about all these things. All these things will come up. And I've got to say, I'm not an expert at all. In fact, when Mickey was saying about doing this, I was a bit hesitant, thinking, "Oh my goodness!" But I thought, well, I've done it for a couple of years now, and I thought, let's give it a shot. Let's see what we can do. And really, for me, I think using it day to day really helps a lot. I think that way, you get used to it and stuff. And I was using it as a glorified. I remember back in our old job, Mickey, we were working together. I was using it as almost a glorified backup system because it's so great for that. I mean, it's a great way to be able to see what have I actually changed. We were using things like Beyond Compare and things like this, and really, that's such a small subset of what Git can give you. But it's a great, kind of thing. You can still do that stuff where you're like, okay, what changed, and what give me a diff on these files, etc. And it gives you a history through time, allows you to see what why that file changed and things like that. So no, let's start off. So I've got my terminal open, and what we're going to do is we're going to make up a new file folder.
Can I just before we jump onto that, can I just discuss one other sort of misconception that I think I have, and I think other people have tried to kind of say no, is kind of the idea that Git is a deployment. What's the word? A deployment platform. That's not really what it is.
That's a good point. I mean, it's not a CR, it's not a continuous integration. It's not it's not a deployment platform. It's not like Capistrano, Fabric, and things like that. It's a version control system, so you can actually do it for anything that you want versioned. You can use Git for. I mean, typically what happens though is you will typically see people, especially in a continuous integrations sense, that when they push to master then is listening. There's a Git hook on it where then that build then gets built up, cloned to the deployments, to the server, built, and then eventually deployed. So you can kind of get that melding where you're taking advantage of the fact that you're checking out the source code and stuff, but it's not. You don't need to. It could just be an rsync. It could just be copying the files what are in the working directory. And that's kind of the beautiful thing about Git, is that it doesn't really infect your files at all, really. And I'll show you that. So what we're going to do is we're going to make up a simple, trivial, well, it's just going to be, file exists. There we go. That's great for me, innit? So we make a directory.
And we're going to watch you, or you want me to do this in sync, or?
Oh no, that's fine, mate. Just watch me, and we'll go through it all, and we'll go through. And we've got bar, so we've got bar for this. So okay. So we now have got a folder called bar, and we do a tree on it. And tree is a Unix command that technically, just essentially what it does, it will print out the directory for us, and will recursively print out the directory, which is great for us because then it allows us to actually see what's going on. So what I'm going to do is I'm going to touch a file. So I'm going to just say, let's do a file called foo, and it's a text file. And we do another tree, and you can see there, so it's just built up this foo.txt file. Let's go into foo.txt, and let's just add some text. So let's just do hello world. Okay? And we're going to write that out. And if we cat that file, you can see we've got hello world in there. So that's great. So what we can then do is we're like, okay, well, this is great. Let's assume this is something that we want to, preserve. We want this, this state in time where this foo.txt file was there and it had hello world in it. We want to keep that. So we're going to use Git for that. And the way we start off using Git in a basic, but a bare repository, not bare repository, that's the crossing of terms, but what we do, a bare folder, which has got no version control with it, we just do a Git in it. And if we tree that now, you'll notice, whoa, look what's happened here. So what's happened is we've got our foo.txt, and then we've got this hidden, because if we ls, we can't see it. And it's because it's a .git folder. And this .git folder has a lot of things in it. And essentially, really, you don't have to worry about the .git folder. But I found when learning it, it's quite good and quite interesting to learn, at least understand where these things are, what's happening under the hood a little bit. Yeah. So you'll see here, we've got the head. And head is the current, head for us is where we are currently at. So where the working directory, because the working directory is all the files and folders that are outside .git, really the source code that really matters, where that is at. So what state in time that is at this time for us and where we're playing it from. And then you have things like objects. Objects is where all the magic's going to happen. And at the moment, that's all you need to worry about. So what we're going to do is I'm just going to quickly get out of this folder and back into it because... ignore me there. But what I'm going to do now is I'm going to do a git status. And a git status will now look and say, okay, what's different in your working directory to what you've got currently stored in your .git folder? So because your .git folder, if you remove that, you've lost all your history. That is the source of truth. And the joke, the tricks are, and we can play around with it, is that you can actually remove everything from your working directory, just generate it all from the .git folder, which is quite fun and quite scary. So we've got this untracked file here, and you'll notice that there is no commits. And you can notice that actually by just looking here, and you notice actually there's no objects. So there's nothing in this Git folder, or this Git repository. So what we're going to do is we're going to say, okay, let's git add foo. And what this will do now is, if we do another tree, it has generated this file. And you can see here, so it's added it. And it's actually added it to the index. So git add adds it to the index. And what that is that's the staging area. And what that does is it actually dumps it into your Git repository. So it's saying, okay, this is a snapshot in time, because what I can actually do now is I can go to foo and I can just say, actually I don't want to say hello, I want to be like, oh, it doesn't actually want to work, does it? Let's try this. Why is it doing this?
Didn't use nano, you need to
So instead I want two. I want to be really, really positive on this stat. And if we do a git status now, you notice we've got the modified file, we've got this new file. Now in the new file though, there's nothing been added yet, but this is the snapshot of that file. So what I'm going to do is I'm going to be really is kind of off the cuff. I love that saying, off the cuff by a podcast. And I've got here we go. Nope, that's not the one. The internals are git. And what we're going to do is, you notice here, so this is me playing around with it, but we can actually do there is a file called cat. Here it is, cat file. And similar to how cat works in Unix world, where you can just cat a file and it will dump it out. If you do git cat file and then -p, but -p says it will work out what type of file it is or what type of object. What you can do is you can get the object, you can see what's inside it. So you'll notice here, if we go here, look at that, hello world. So it's added hello world, which is great because that means that, okay, so that file has been preserved. So there you can see the contents of that file has been hashed. And this is actually the hash, the SHA-1 hash of all the contents of that file. And that's the beautiful thing, because anything changes, it will only change the hash and it will make a new version for it. But anyway, yes. So let's say, okay, well, I just want to commit, the file that I already had. So we're going to do git commit, and we're going to do init commit. And what this is saying is committing it, and it's saying please put the message, because it's nice to actually have a message for what happened. It's going to timestamp it. It's going to give it the name of the person that did it. It's going to give me, what time I did it, and also it's going to give this message, a bit meaningful message. And then if we do a git log, you'll notice there we go. So you can see that this commit message here, this is the commit hash. This is the name, so this is me, that I'm the author of this commit. And you can see that it was Tuesday, September the 8th that we did it. Now you'll also notice though that I've still got this modified file. I don't want that anymore, so I'm going to say git checkout dot, and what that's going to do is going to replace everything that's in my working directory with the currently last, the commit that I'm currently on. And that can be a bit scary, because you see now I've actually changed, and it will have now changed that file back to what it was. So it was back to that. So you can see that we actually generate in the working directory by the files that are in .git. And if you look at .git again, you'll notice now we've got 3 files. And what these files are, so if we go through them all, so we've already got that. So we've got, let's do this. So yeah, we've got the AF one, and you don't actually have to type all of them in. It has to just be enough to actually be able to work out what the actual file is. So if we look at this, you'll see here, oh look, there it is. So that's the commit hash. So what's happening is the current head, which we'll talk about here, the current head file is saying, oh, the last commit hash is here. So it's linking to this hash here. This is saying, oh, it's the name of it, commit, init commit. The commit is me, the author's me. Saying the tree. Now the tree is an interesting one, because what tree then does is tree allows us to then, because obviously the working directory or the file directory is built up of files with contents and the directory structure. And the file contents, some of the files could be exactly the same, but just have a different name.
Yeah.
So what this is doing is saying, okay, well, currently we have a working directory, or we have a directory, that is just with a foo.txt. It's a blob, a type blob, because you can have other trees, because you can have other directories. It's saying these are the working permissions for it. So these are the Unix permissions, and this is the location to that file. So this is a little bit in depth, but what the nice thing about this is you can see that there is no magic really. These are just, it's called a DAG, which is a direct asynchronous graph. And essentially what that is just the ability to be able to represent in tree format these files. And the beauty is okay, and what another beautiful thing, so the beauty is here. So what I'm going to do now is I'm going to get out of that, and I'm going to finally go back into it. And now we see master come up because of my lovely liquid prompt thing that I'm using, but this is saying, okay, we're on master. So we can look at git branch, and you can see we've only got master. And if we actually cat.git head, you see we're actually referring to the master. So this is saying head, oh, by the way, we're on master, and that's why we're on master. If I touch another file, and I just go, so we've got a file called foo. Let's do a file called baz. And then let's just go into that baz file. And let's actually just type the exact same thing in again. And if we git status it, it's going to say, oh, we need to add it. So we're going to add it. We're going to add the file in. And then we're going to do a commit. And we're going to do add baz. Now, this is one thing actually that is good etiquette with commit messages, is you actually want to be thinking about, think of when you're writing your message as an action, not as something you've acted on. So not saying, oh, I added baz. Think of it as something like this commit will do this. So, add baz. So this will add baz, not I've added baz in this this commit.
Okay.
That's a very good etiquette to be, because it's an action, because it's saying when I actually run this commit, or when I execute this commit, it's going to add baz, it's going to do this, not added baz, in the past tense, because it isn't that case. So we've now added that file in, we've created it. If we do a git log again, we've now got 2 files. So we've init commit, we've got 2 commits. We've got the init commit and we've got the added baz. If we get git status, we've got nothing else there. If I ls, we've got our 2 files. But if I go in here, you'll notice actually that we've only added another 2 files, or another 2 objects. And that's because, so let's actually go through them all. So we should have another git commit object. So if we go through these commits, so if I go up here and we go to OF020, There you go. That is our file structure. Our directory structure. This is our tree. So you see now this is for our second commit, and it's saying, okay, we've got a foo.txt and we've got a baz.txt. And if I go to 5e3c, that's our init commit. Okay, that's cool. That's saying that it's for that tree. But if I go to, and this is just like a little game trying to find it. That's not the one we want. It's for ed49. And you can see here, this new commit is saying, oh, my tree's this, which is this up here. And my parent is 5e3c. And you notice here, this is that commit hash. Because so this is saying, yeah, I am that commit. So you can see 5e3c, this is my parent commit, and my tree is here. And what you'll notice actually up here is the hashes are completely the same, because the contents of the file was completely the same. So this is actually redundant. This is in itself, it is actually self-deduplicating, because it will only store that same file once, even despite of any commit you're doing. Even if you've had that commit, that file was one time that, and then in a year's time you change it and you commit it again, it will use the same object if it's the same file. Only the things that change are the file extent, file permissions, and the actual name. So I don't know if I'm going too in depth with that. I just thought that's quite an interesting thing to see, that there's no magic with it.
Yeah.
So we've got these files. So we've got a Git log. We've got our 2 messages there, and let's actually get some work done. So what we're going to do is we're going to tailor between me and Mickey. I thought is quite a good idea, where we're going to be doing a shared environment, or actually no, sorry, we can do it even here, and we can just do like the idea, because I think this is quite simple. This is quite understandable. We're adding our files in. So say I want to make a change, so I'm going to go to foo, and then be like, well, actually, I don't want to say goodbye world anymore. Hello world, I mean. I want to say, well, goodbye. Goodbye world. And you'll notice here it's come up red, and that's because it's got modified. If I go git diff on that, we can see what's happening within my working directory and my current file. And you can see here that, okay, foo.txt has changed from hello world to goodbye world. And we can go, okay, let's add and dot. And add dot essentially means add any file that needs to be changed. Or it's adding any file, whether it's a new file or it's a file that has already been added into your index or into your Git repository. I'm going to add it. Just
to step back one step. I know you already said this, but just to confirm. So if you did a Git checkout now, goodbye world will be overwritten with hello world again.
That's it. That's absolutely it. So git checkout. Yep. Git checkout, and because essentially what git checkout are doing is git checkout master, where it's doing the current branch, checking it out. Yep. It's already a master, but if I go checkout dot, it's gone. And we've now checked out all of it. Now what you can actually do, so if I change that file again, so if I go, okay, goodbye world, we've got that change. I can actually I also then change baz to, and I do something like that. So now you'll see we've got 2 files changed. But actually I'm like, but I don't really want baz to be that. I want it to be what it was in master. Now you could go through the case of going through, maybe going on GitHub, finding the file what it was, and copy and pasting it again, and it'll be fine, and ignore it. But what you can actually do is you can just git checkout, master -- and that says only I want now a file, baz, the location, and it will only check out that file again. So you don't have to do a full nuke. You can do specific files and folders. Okay? So now you can see git status, and if we now do a git add and a git status, we now added that modifier. It's actually on our index and it's ready to be committed. So we're going to do commit and we're going to say update foo text. And we do a git status again. There's nothing on there. Git log. We've got our history. You go here. We've got a couple other objects in there. So we've now got those files. So these are the files we want. We've been working on it locally ourselves. We now want to actually give it to someone for them to work on. That's a typical pattern. So we've started off master. We've done that and everything like that. It's great. So what we're going to do is we're going to go to GitHub and we are going to create a new repository. And we're going to call it foo barbaz. and it's public, and we're just going to say that's fine. And we're then going to... So you'll notice here, this actually gives us all of the actual, commands that we need, but we're going to go and talk through them all. We've actually done 4 of these steps where we've actually created a file, etc. And then we've added it and committed it, and now we just need to actually add the remote. So we're going to go back here, and we're going to go git remote add. Git remote add. We actually need to specify what we want to call this remote, and we're going to call it origin. So you don't have to call it origin. That's just a good standard similar to master. You have a master branch and you have origin, which is your base place that you're pushing things to. So essentially what we've actually done there is, so we go to remote, and I think it's verbose that we want. Yeah, so we've actually only got, so we said this local Git repository now has a home, or has a place that it can now go and push and fetch from. And this is saying, okay, the origin here, so this is saying the origin is now the GitHub repository. So what we can do is we can go git push origin master, and this is going to say push to origin my master branch. Okay, and you see there it's made a new branch in this Git repository. We refresh this now. Well, hey, look at that. We've got all of the files and we've got all our history. Okay. So now that's great. That's live in our world. Now we want to get on with some ideas of how am I going to work with this in branches, etc. like that. So a feature comes down the line for some reason that we want to change foo from goodbye world to bonjour. For some reason we want to do that. Okay, and Baz we want to delete. We're like, no, we don't want Baz anymore, we want foo. Okay. So what we're going to do is we're not going to actually do it in master. That's live. We don't want to be editing lives, files on live, etc. like that. We don't want to be playing around with the commit. We don't want to be adding files to master that aren't on live. It makes no sense. That needs to happen. It needs to be all agreed on beforehand. So what we're going to do is we're going to go git branch. So it's going to git checkout B, and we're going to do French for some reason. And what this has done is it's firstly checking out the branch French, but French doesn't exist. -B or -B means create that branch French too. So if we now look at branches, you'll notice here we've got a master branch and a French branch. Now French branch at the moment's referencing master. So it starts off its life as being whatever master it was at that time. That snapshot of that commit. So it's actually that commit here is what it is. Update foo text. So what that means then is I can now do some work. I could be like, okay, well I've got my git status on here. Nothing's there. It's cool. Let's go to, what was it? We're going to say that foo now, instead of being that, and I can delete all of that. Go away. I'm sorry. Go away. You know what? I'm not having the best of luck at them today with this. Let's do that. Let's go in there. So goodbye. I want that to be bonjour. Okay. Git status here. Boom. Modified file. We can go, okay, let's analyze what we want to do first. Okay, yeah, that's cool. We're happy with that. And another thing we wanted to do is actually delete a file. So we're going to remove Baz. Git status. Okay, so we've deleted Baz and we've modified foo. Okay, awesome. Let's add all those changes in. We'll do git status there. They're both inside the index, ready to change, ready to be committed. Git commit. Change to French. Git status. Awesome. We do a git log. Now, this has now got change to French. If now someone comes along and says, actually, master, I need to check out something's happened on master, we need a bug fix quickly. We look at git log, on master, and you'll notice that the git log, this still only has history up to update foo text. And if we ls, it's still got all the files in it. That's because master doesn't know anything about the French stuff yet. It knows nothing about that stuff that's happened with the deleting and the updating of the file, etc. So what we can do is we're like, okay, well, we need to put the French stuff on the back burner. We need to change a file in here for some reason. So, okay, we've got a quick bug that we need to fix. So we go to foo, and we're like, actually, at the moment, we need to do that. That's the bug fix. So we're going to add it. Git commit, bug fix, foo bug. git push -u origin master. What the U does is it updates your tracking branch. What essentially means is that your branches, so it'll say anything that you have on your personal master branch, it will check to see what the origins master branch has as well, and it'll be able to do a compare to say you are out of date with this branch. So you can see here it's set its tracking remote branch to the origin. So that's nice. So we go there and we refresh to here again, we update, fix foo. So we've got that. That's awesome. Okay, brilliant. Now I then go, well, I want to go back to my French stuff. Okay. And let's now go, oh, well, you know, I thought this was pretty good. Let's git push origin and let's call, you know, French because we want to be good. We want to do that. Git push there. And you'll notice, so we've got the changes that we were making. And then we can, so here we go, notice it. So this is a nice way. So then we're going to do a pull request for this. So we're going to say, compare this. So from that, you can't actually merge it. So you'll notice actually there was a conflict between master and French. So this can't actually be merged without us doing something. And this is something that can get you a bit confused. What actually happens here is because we've done two changes. We've done a change on the line. So Git is very clever at trying to resolve conflict without asking you. But if you've done a change on the same line as you've done a change on another line, it doesn't know what you want to do. Do you want to use theirs? Do you want to use ours? Do you want to use a combination of both? So what we need to do is we now need to do a resolution. So typically what we do is what you want to do in this case is I would want to rebase, say, okay, I want now anything that I've done. I don't want to have to do this merge because you don't always have to do a merge. A merge actually makes another commit. And we're going to do a merge after this one. But the first thing I want to show is how you do a rebase. So what I want to do is I want to do a git pull rebase origin master. And what that's saying is go back in time, do everything that master did, and then add on the stuff that I was doing before afterwards. Now all the commit hashes, and this is one thing you should remember, will change. This commit hash here will change. We will not have that hash anymore because its parent was different. Once I've added in here the fix, every hash after that is going to be different because it's amalgamation of all the other ones, which is great. And that's why it's got that consistency and that resilience built in that I know if it's the same thing. If I'm using the same hash as you, it's the same stuff all the way down the chain. So I'm now going to say git pull rebase origin master, and it's going to go bang. And it's going to go bang, and it's going to say status, and it's going to say, look at this. So I know about this change. I'm cool with that. But these have both been modified. What can I do with them? So if we go to this file, what it's done is it's saying, okay, well, change of French is doing this, but this commit hash is doing this. What one do you want? I'm saying, well, actually, I want my one, please. So we can then carry on the rebase. So we do git rebase continue. Okay, and git rebase continue. Oh no, sorry. You need to git add foo. So you need to actually add the file onto your thing first. Then you git rebase continue, and now it's applied French. Now, if I go git log, what's now happened is my change to French. If I do vim foo, is now bonjour, which is exactly what we wanted. And the hash for this one will be the same, hopefully. So let's go here. Let's go to commits. For D, no, that's not the same. Change to French. Sorry, change to French. Because we're on the French branch. Nope, there. 4A06. So we're now up to date with exactly what master was doing. And now we've added on our changes. So if I now do a git push origin bar, or French, sorry, it's now going to have a go at me. And this is good. Because what this is saying now, it's saying you've done some crazy crap now that means that I can't just go along and play from where I started off up in my parent. So where I currently am in here, I can't just add on from here. You've changed history. Now, are you sure you wanted to change history? Because changing history makes it so much harder for people get confused because they're like, well, what's happened? What's going on here? You've just changed the world, the history of what's happened. There's no story for me. I'm not able to resolve this and work this out. So what you want to say is actually yeah, for my branch, I know what I've done. I've done a rebase. And I can now do that. And I'm saying force. I'm saying, yep, please change me. Now, if we refresh, we've got our change. You can see it's changed from goodbye world with the exclamation mark to bonjour, because it's now knows that. And if I go there, I can now do an able to merge really easily. In fact, actually, I don't even have to do a merge. I can do a merge, but I can actually do it with a rebase, where it means it will just apply it on top. But typically what we do is we do something like this, where you've got a pull request and you're saying, all right, okay, please, we have a please review. And you can see here, hello world has been deleted and bonjour. People are going to come across and say, looks good. Okay, that's great. That looks great. Okay, let's merge. And what this will then do is, okay, we want to merge that in, confirm merge. I want to delete the branch because we don't care about it anymore. And you can see foobar, and you can see now we've got the commit, but it's also added a merge commit because this is saying who merged it in and stuff like that, which is quite good information because it allows you to get context of like, oh, why did you merge that in? What was that about, etc., etc. It also gives a link back to the pull request, and that's one of the beautiful things about GitHub is that you have these pull requests. And what we've done there is we've made a feature, and we don't need this branch anymore on here. But if I check out master, and I'm going to do a git fetch. You can see here it says your branch is up to date with master. Well, that's a lie. If I do git fetch, it's now going to be saying to me that it should be saying, yep, your branch is behind by 2 commits because you've got the commit that we made within the French branch, but also the commit that we did for the merge within GitHub. So what we can do is we can say pull rebase origin master, and we can do this because we're actually just replaying itself, because we don't want to do any merges. We're just replaying fast forward. You can see here it's rewinding back where it can. Now it's fast forwarding and saying, yep, I know, I want to be here. And we can git status there. We're now there. I can do git branch, delete French because we don't need that anymore. And we've now finished that feature. That feature's now been done. And it's not been done anything to do with master. We've been able to make a commit in master, do a resolve of that within another branch before actually merging in. And yeah, I mean, that's really it. So Git rebasing on top of things is good for master and things like that. Sometimes you will need to merge in, and doing a merge is as simple as actually simpler than doing a rebase, because it does actually keep the history. So what rebasing is doing is changing your history on your branch. So let's make another one. So let's do a quick other one. So git branch, git checkout, and let's just do one called Baz. So this is Baz. This is just making a new branch called Baz. Let's add a file. Git adds. Let's just do touch cheese, because we have to have cheese in here. And then we do vim cheese, and we're just going to do cheese. Okay. Git adds. Add all the files. Git commit. Add cheese. Yep. Git checkout master. Now I could push this up and everything, but I just usually want to do a git merge. And this could actually be done with just a rebase, but I'm going to do a merge just because we just want to be safe. Git merge cheese. And you'll notice here that it's probably been clever enough. No, has it been clever enough to do it? I don't think it has. Git merge cheese is not something we can merge. Why can't you merge git cheese? Git merge. Cheese is a branch. No, we had Baz, didn't we? So yeah, so we've now merged in Baz, the branch Baz, with the fast forward, and you notice it's actually been clever. So it hasn't done a merge thinking there's any history, it's fast forwarded, it has done the rebase for us, and it's actually just added in that file on top.
Okay.
And then we can push origin master. And because it hasn't rewrote any of the history underneath it, it's adding on top of it. It doesn't need to forcefully do it because it's not removing anything.
Sure.
And we go here, and you can see that we've done it. So that's kind of like a high-level view of things. I'm just wondering, is there anything there that's stupidly crazy?
I was just going to ask you, really, I mean, like the way you talk about rebasing, are you sort of implying that you want to avoid it if possible, or are you saying that it's just...
It's good. So rebasing's great because it allows you to change history. So if I'm working through a big pull request and I've made a lot of commits and I want to clean this up before I move it, like I'm doing temporary commits saying, oh, does this work? I can rebase it. And what I can actually do is change history. So it's good to be able to clean up your history before you merge in. Now, once it's been merged into master or something that's live, you shouldn't be rebasing. You shouldn't be changing the history. You should just do, things such as, okay, I need to revert this commit. You actually have to make a git revert. So you do have to make another commit that reverts that commit. You can't just change and remove that commit and say, it didn't exist, because people now rely on those commit hashes. So rebasing is great for clean histories because it will all be linear, because you're just applying on top of each other. Git merges are great because what they do is they maintain the history of what both of the people did, and then it will come and join together afterwards. So it's almost like you break out, you're all doing your own little worlds, then you merge back in, and then it's able to say, merge conflicts, what it needs to deal with and stuff, and then goes back in. So you've got that history and you maintain that history. Whereas with Git, with rebasing, you change the history and you lose history. Now the interesting thing is, though, is with Git you don't actually lose stuff. So whereas you think you can lose things because of the fact that it is all objects. If I'm looking at my tree, I have all the files here that we've all created. Even some of these may not even be needed anymore. Only when I do something called a git gc, which is a garbage collection, does it actually remove any redundant files. So what I can now do is do something called a ref log. And what that will do is it shows me all the history of what happened. So you'll see here, okay, I did my initial commit, and it was with that hash. I committed add baz. I checked out moving from master to master. I checked out, foo text. I did all this, and you can see where all this history I've done. So I can go back in time and I can pick these commits up and then add them back on again and stuff like that. And you can do things such as cherry picking, which essentially says I want that commit from that branch on this branch, and it's able then to bring that over on its own. So you can do these really advanced things, but one thing is people get scared, and I got scared a lot about thinking I'm going to break things, but you can't really break things unless you're really clever, you really want to destroy it. You can get yourself back into a good way, and that's because it's immutable. It's a functional graph. It's immutable. There's no one change doesn't actually change any previous things. It just adds on the changes to it. Another one. It creates a new one from it, which is quite amazing. So I'm just wondering, is any things you want to kind of want me to go over?
Something we kind of glossed over really is something obviously we've both done, but I guess depending on how much knowledge that people are listening have, obviously we looked at your GitHub account, but I guess some people might have heard of GitHub or Bitbucket and never really used it or really know what it is, I guess. So I don't know if it's worth us talking about what they are.
That sounds cool. Yeah, I mean, I think I may have gone over some pretty advanced stuff just for really beginners, and I'm really sorry about that. I think that may have scared people away. But essentially, so the commands that I've been using for these examples are very are the way you want to do it, and the underlining backing stuff is for geeks who actually like that stuff. So within the video we can kind of chop that up and make sure that it's specific to the areas.
I mean today's been a good way of just doing like an overview of everything, and we can review after this one and have a look at stuff maybe we went over too quick, and
that's exactly it. Yeah, people can be like, whoa, okay, this is over my head now, what we need to do and stuff, and we can go through and slowly build up. So essentially what GitHub is, and things like Bitbucket is, these are free, but then you can get paid versions of them, online Git repository hosting platforms. And what they do is they allow you then to publish your code online or publish your Git repository online. So that's really what it's doing. It's not publishing your code, it's going to your Git repository. And then all these here are all your work, is the working directory for that Git commit, or for that, commit you're working on or you've been on. So you can see here that I can actually go through history and be like, okay, I want to go to this commit, and you can see this is what happened in this commit and stuff like that. I can browse the files from this commit, so it can go through. So it's got the whole history. So what you're able to do here is actually, for free, or paid if you want, extras and stuff, is to actually host your Git repositories online, so other people can you can work and share code with other people. You can share your repositories, be able to work together, be able to work in collaboration on projects and stuff like that. And that's really the beautiful thing, is because I've got all the code on here. Now, if Mickey goes to this URL and wants to pick it up, he can now go and get all the code. He can now do a commit, and work from that. And the nice thing with these platforms is they do have user permissions and stuff like that, so you can say who's allowed to work on it, who's not, etc. like that. So you can see here, contributor to this is currently only me. And I'm able to do settings, so I'm able to say like who owns this, collaborator. So I'm able to add, people in, etc. So I'm able to like say, oh, Mickey works on this project as well. So they deal with all that stuff for you. Really, you don't need a platform like this. You could just do it locally. You could just, have another box that you then get, clone. You merge. What happens is you just have it and you pull down the changes. But you have like your own Git server, but using these platforms is really easy, and stuff like Bitbucket I think still does the private repositories, so you can just have all your code if you need it, if it's important that it's private, it's
you get the beauty of the nice interfaces, and I wasn't sure if that was still the case, but certainly like Bitbucket you can have free private repos, whereas GitHub I take it you still can't do that, right?
No, I think you have to pay for the private repos, but yeah.
Sure.
So I mean, the funny thing is that me talking about pull requests and things like that. That's very much kind of like this social GitHubification of Git, and that's the great thing because but that really does come into the flow of things. If you're going to be working with Git, and you're going to be working with people with it, you're going to make pull requests and you're going to ask them to work with them, and review them and then merge them in eventually and stuff like that. And it allows you then to maintain your source of truth of this master, move on to another branch, do some work. Say, crap, I need to rebase master into my branch, which essentially means I need everything that's in master onto my branch so I can easily merge it back in, or I need to, maybe there's a fix that I need to work with and stuff. And, it's not as scary as you think. The thing is like I use things like, I've been playing with the command line today, but, I use terminals, so I do use, GUIs. And and these are great because these allow me to easily see what's going on. And you can see what's happened, and you can read here, and you can be like, oh, actually, I know what this means now. This is just the voodoo that's within the object file. .git folder. It's not anything that's out of reach. And you can see here, this has only got one branch. It's got one remote. The remote is to a master, and I'm pushing to it. So this is this is just a nice interface for that. The images, they just come from Gravatar because it works out from the email hatch, so there's no magic there. So I think that's kind of a nice overview. Maybe probably hitting a couple of too complex topics for a beginner thing, but I think it's nice just to get that overview of like, okay, well, because I think a lot of people have already seen the simple backup kind of git add, git commit. It's like, well, hang on, how do I work with another file, and then how do I merge them in and stuff like that, and this is how you work with it.
I don't know if it was worth maybe we'll switch over to my screen and I would clone your repo and maybe make a branch and push something up.
Yeah, let's do that.
Demonstrate collaboration.
Go for it, man.
Let me just check my screen is safe. Okay. Cool. Right.
You need to switch your screen over.
Yeah. Oh, right. Yeah. Okay.
Here we go.
Okay, so if I I am now going to go to your Bitbucket account.
My GitHub account.
GitHub. Okay, which is github.com/edman.
Yeah, .com, /edman.
Hope if I could type right. That's going to take 7 years to load.
And then you go to repositories. And then you go to foobar baz, yep. And then you just want to copy that bad boy in.
Okay. Does that give me... Oh, no, it doesn't. Okay.
So you want to git clone, yep. So you're getting clone in, and that clones into the foobar baz folder. So it's creating a foobar baz folder based on the repository you're in. And then you cd into that. And there you go. You've got the cheese and the foo because that's the last master commit.
Okay, and then I can then make my own branch.
Yep, make your own branch. That's there. So that's created it. It's checked out the branch Mickey branch, but because it doesn't exist, it's also created it using the $B.
Sure. So now I'm not going to make a change to foo.
Okay. You really just want to be admin all the time, don't you?
I keep forgetting that. Okay, write that out.
Okay, so then you do a git status on that, and then we can see what's going down. Okay, we've made our modification.
So I now want to add foo.
Yep, you can add foo. Now, one thing here actually is, yes, I mean, that's a okay size git commit, because what you'll have is typically it's like 80 characters long is what you want a git commit message to be, like the title. And what you typically do is you won't use like the command line for if you've got like a big bit of text, because what will happen is you'll notice that in things like Tau, what they have is a title bar, and then they have like a description, and essentially all that is it's just you have your title, you leave a new line, and then you do the big description. But this is fine for this case where you've just got it on a single line commit.
Sure. Okay. Right. So now I've got this. Now I want to push it up to our.
Now you want to push it up. Now you don't actually have access to accessing my version of the Git repository. So what I'll do
is create a Git remote branch.
Right. So what you need to. So what you'll find if you do Git remote on yours now is you've got origin. Oh, sorry. If you do Git remote -v. Okay, you'll notice that it's pushing to mine. Now, if you try and push that, so if you do git push origin and then Mickey _branch, password or username.
So, wouldn't it? Okay, let's try this.
Yeah, there we go. That's it. So what's happened here is you can see it's unable to access because the URL returned 403, meaning you don't have access to this file. So what I'll do is I'll quickly just say foobar baz, and I'll do settings, collaborators, and I'll say Michael Budd, add him as a collaborator. So now he has push access to this repository. So what you should be able to do now, man, is you should be able to rerun that command.
Okay.
Type in your username and password. There we go. And you can see there, so it's actually pushed it up and it's created a new branch. So if you go to and go in there, refresh, you'll see we've got one branch up there at the moment. It should pick up the other branch. There you go, 2 branches, and it'll be from you. And Mickey branch updated by Michael Budd a couple of seconds ago. And if you do, so now what you need to do is you need to log in. So you've made that branch, and you're like, look, I really want this now to be part of something. We may work on it together, we may collaborate, we may, this will then be when it goes through a Jenkins build or something like that.
Yeah.
Sort it out, there we go. And it's remaster, merge this now. Okay, and then you're like, okay, leave that now for review. And I'll come in and I'll be like, what's going on here? Man, sort it out. I'll look through the diff and I can see you've just changed bonjour to bonjour Claire. I'm like, that's a great change. Merge it in, delete the branch, job's done. Now, what we'll notice there is we'll go through the commits and you'll see the history. So this Michael Budd, this will change the text inside, and you've got your Mickey branch and we've still got the pull request. That's the beauty of something like GitHub. Now, what you can do now, though, is what you want to do is you want to keep your files in sync. So if you do a git fetch, you'll notice that there's some history, so the things will happen. There we go. So it's updated. It's saying, oh, master's now been moved. So if you don't do git checkout master, and then git log, at the moment, you still got just add cheese. And that's because your current personal master doesn't know about those changes. It's got it in its history to be able to work it out, but you've still set it that your master is at this commit. So what you want to do is do a git pull rebase origin master. So it's git pull and it's dash rebase, sorry. And what this will do is it will replay, and it will then, so you won't do any merging, because sometimes you get these typical difficult merges if you try and do it without something like this. This will fast forward and it will just say, look, okay, now we're at this. And if you git log now, you'll see all your changes, your 2 commits, one where you actually did your commit and one where I merged your commit in.
I'm with you.
And there we go. Okay. And that's kind of a typical workflow.
Very nice.
Okay, I think maybe that's it for the first video episode, but I think that's been quite a good rundown.
It was good info for like the first one, I reckon. So it might be good next time if we could look at like Tower and what's Source Tree? Is the other free?
Yeah. Have a look at these, and I think you know what I mean. Learning the commands is great. I typically use just a GUI still. I know the commands, but I prefer using a GUI. For me, it really works out better. I just love seeing, it's a lot easier for me to quickly do things and stuff like that. But, that's for preference. But, in the next video, we'll carry on. But I think for now, we might as well wrap it up and call it an episode.
Hopefully there's some time for people to say, oh, you didn't go over this, or can you go over this again?
That's it, yeah.
So if people send any feedback, we can have a look at stuff again.
Absolutely, that sounds great, man.
Thanks, Edman, for going through that.
Not a problem. It's been good fun. All right, then, audience. Yeah. Well, we will see you for another video episode or audio episode or whatever we do next. We'll just kind of randomly putting them out whenever we can. When we can. Yeah. So, audience, it's been great speaking to you and you seeing us, I guess. And see you next episode.
Cheers,
Bye.
Guys. Thanks.